what are the different components of a linked list. So let's get started. So here we have a typical linked list having lot of square boxes and arrows. Let's understand what is the meaning of them. So the first component is a node. Now what is a node? A node is basically an element of a linked list which is having data and reference to the next node. So here we see we have multiple nodes. This is node 1, this is node 2, this is node 3 and so on. Now in a given node, as we can see, we can store some data. Like here we have stored number 20. Here we have stored number 30. Similarly, we can also store any other thing like a string. So instead of 40, if it was a string type data, we could have saved, let's say, ABC. Similarly, here instead of 50, we could have saved XYZ. Of course, the data type needs to be string, else we will not be able to save ABC or XYZ. Now the second part of a node is nothing but reference to the next node. So in this case, the reference to the next node is 333. Now what do we mean by reference? So this node here, which is node 4, will be saved in RAM in some place, right? Now the physical location where this node is stored, let's say the physical address of it is 333. So this address 333 needs to be stored in the previous node, so that when we visit node 3, we know where exactly in memory the next node, that is node 4, is existing. So we come to node 3, we see that the value is 333. So we know that the next node is sitting at 333 location in RAM. So we get to this node. Now once we reach node 4, we need to know which is the next node. So the next node is sitting at the location 444 in RAM. So by that way we can reach node 5. Similarly, from 5 we can reach to 6. And in case of 6, we see that it is null, which indicates that there are no more nodes after this node. That means node 6 is the last node. So we have seen that node is one of the components of linked list having two parts. Part 1 contains the data and part 2 contains the reference to the next node. Now let's see the next component of list. So the next component of a linked list is a head. So as we can see in the diagram, head is the first component of this list. So it basically stores the first node of a list, and we ideally always start from head and go till the end. So in this case we see that node 1 is the first node and the physical address of this node 1 in RAM is 001. So in head we store a value 001, indicating that the first node is residing at this address. And then once we visit node 1, we know that the next address is 111, so node 2 is at 111 value, and so on. Now why do we need a head? We need a head because if we don't know where the linked list starts, then how will we access this linked list? Now the last component of a list is a tail. So what is a tail? Tail basically references to the last node in a given list. So in this case we see that node 6 is the last node and the physical address of node 6 is 555. So we store this value 555 in tail reference variable. Now you might be wondering that why do we need to store the last element separately? We can always start from the first node and keep traversing towards right, and ultimately we will reach the last node. Then what is the use of storing the node 6 or the last node separately? So that is a very valid question. The answer to that is, if we don't store the address of last node separately, there is a small problem. The problem is, if we want to add, let's say, one more node called node 7, in that case we have a problem. Problem is that to add one single node, we have to start from first and keep traversing till the last, which will unnecessarily take order of n time. But if we can maintain a last variable's address, that is tel, all that we have to do is we access tel, that is 555, and do a linking, and we are done. So this operation will basically take just order of one time. So to improve the time complexity, we are also maintaining a tel reference variable. But again, it is not mandatory. If you don't wish to maintain it, don't do it. But for time efficiency, we should always do it. Fine. So that is all for this video. In the next video, we'll talk about what are the different types of linked list that we can create. Thanks for your time. See you in the next video.